Hey everybody, my name is Brandon Barney. I'm Section 1, Fundamentals of Physics. This is my video podcast. Today I'm going to be demonstrating the balloon rocket experiment. First I'll show you how it's created using simple everyday objects. Then I'll actually show it to you in action and go in depth on the physics behind it and how it actually works. So let's check it out. Alright, first things first. What exactly do you need to create a balloon rocket? It's actually pretty simple. First off, you need a couple pieces of tape, some string, straw, any straw will do. A lot of times people use two chairs. Really it can be any sturdy object as long as they're about the same height, and some balloons. I'm going to actually set up the experiment before I show it to you. Then once everything's ready to go, I'll demonstrate it and explain to you how it works. Alright, let's go. Alright, now for the fun part. As you guys can see, I've already set up the experiment. Pretty much I've taken two chairs, set them across the room from each other. I tied a string in between them. I also fed a straw along the string. This is pretty much going to act as the track so that the balloon flies in a straight line during the experiment. Alright, now I have a balloon. As we all know, balloons are made out of an elastic material, and they contract on whatever air is blown into them. So when I blow this up, pretty much as long as I pinch off the end and tie it off, the air has nowhere to go. Therefore, the air pushes back on the balloon's walls, and that's why the balloon retains its shape. Now, as you can see, just like it's going to be in the experiment, the mouth of the balloon is actually going to be open. Now, since the mouth of the balloon is open, the air then has somewhere to move. And since the air is moving, due to Newton's third law of motion, for every action there's an equal and opposite reaction, and the law of conservation of momentum, the rocket balloon itself must then move as well, which is why in a minute we'll see it shoot forward. Alright, let's just recap what we just saw. First things first, I had a balloon. When I filled the balloon with air and pinched off the end, the air had nowhere to go. Therefore, it pushed back on the walls of the balloon, which is why the balloon retained its shape. Now, during the experiment, I let go of the balloon. Now, as soon as I let go of that balloon, the mouth of the balloon opened, which then immediately gave the air some place to go. Now, because of Newton's third law of motion, for every action there is an equal and opposite reaction, and the law of conservation of momentum, since the air is moving, the rocket balloon itself has to move, which is why we saw the balloon propel forward along the track that we set up. So basically, to put that in simpler terms, the balloon pushed on the air that was released, and therefore the air pushed back on the balloon, which is what sent it forward. Secondly, we didn't really go into too much depth with this during the experiment, but if you were getting into real minute details, things like that, you'd normally take friction into account. However, for this experiment, since the straw that we're using is smooth and has a really low coefficient of friction, and the weight of the balloon itself is very light, the overall force of friction is really low, so it's pretty much negligible for this experiment. Alright, with all that said, I believe all the fundamental principles were covered. Once again, my name is Brandon Barney in Section 1 for Fundamentals of Physics. And this was my video podcast for the balloon rocket experiment. Most importantly, I hope you guys enjoyed it and found something interesting and learned something new that you can take away for future reference. Enjoy.